Hello guys, this is Ogezi Chedoze from Special Maths Academy. In this video, we're going to be solving question 8 of 2021 Senior Maths Olympiad first round. The question goes like this. Given four numbers a b raised to power 4, a cubed b squared, a raised to power 6b, and a raised to power m b raised to power n, where m and n are natural numbers, it is known that one is the geometric mean of the others. Find m plus n. So the mean of geometric mean is, for example, if we're given numbers 1, 2, 4, and let's say 8, and we're told to find the geometric mean of this number. What we're going to do is that we have four numbers here, right? So we're going to take the fourth root of 1 times 2 times 4 times 8, and then when we calculate it, that's going to be fourth root of 64, which is 4. And that's what it is. So in general though, if you have numbers a1, a2 up to an, the geometric mean of these numbers is going to be the nth root of the product of all the numbers an. So that's the meaning of geometric mean. So now we're told to find m plus n. Then the first thing we're going to notice is that a raised to power, and we know that one of these numbers is the geometric mean of the others. That's what we're given in the question. So the first thing we're going to show now is that a raised to power m, b raised to power n is not the geometric mean of the other three numbers. Then to show this, it's just as easy as find the geometric mean of these three numbers and showing that something will go wrong somewhere. So the geometric mean of the first three numbers, a b raised to power 4, a cubed b squared, and a raised to power 6b, is going to be the third root, since there are three numbers, of a b raised to power 4 times a cubed b squared times a raised to power 6b. And when we simplify this, it becomes a times a cubed times a raised to power 6 is a raised to power 10, and times b raised to power 4 times b squared times b is b raised to power 7. And when we look at this, we end up having like a cubed b squared root ab. I'll write this as, it becomes a raised to power 10 over 3 times b raised to power 7 over 3, which is a raised to power 10 over 3 b raised to power 7 over 3. And if you notice, if a raised to power m b raised to power n is the geometric mean, and this is the geometric mean, it means that a raised to power m b raised to power n is equal to a raised to power 10 over 3 b raised to power 7 over 3, which implies that m is 10 over 3 and n is 7 over 3. But don't forget, we have that m and n are natural numbers, and these two numbers are not natural numbers. So that's a contradiction here. So we know that a raised to power m b raised to power n is not the geometric mean. Good. And so from this point onwards, we'll now take a different approach towards the question now. So let's assume that the geometric mean, which has to be one of these three numbers here now, is a raised to power x, b raised to power y, right? So a raised to power x, b raised to power y is the GM. Cool. And then let's say the other three numbers now. Sorry, the other two here are a raised to power x1, b raised to power y1, and a raised to power x2, b raised to power y2. So for example, if a raised to power x, b raised to power y is the second, then this will be the first and this will be the third. If this is the third, this will be the first and second, just something along those lines. And then the last number now will be a raised to power m, b raised to power n. Cool. Then when we're calculating, then the geometric mean of these three numbers that we have here, which are the three numbers apart from the one that is the GM, is going to be the third root of a raised to power x1, b raised to power y1 times a raised to power x2, b raised to power y2 times a raised to power m times b raised to power n. And this is going to be, if you simplify it, that's going to be the third root of a raised to power x1 plus x2 plus m, b raised to power y1 plus y2 plus n. And this is a raised to power x1 plus x2 plus m over 3 b raised power y1 plus y2 plus n over 3. Okay. And then since a raised power x b raised power y is the GM, this is going to be a raised power x b raised power y. And then based on this implies that the exponent of a will be equal to the exponent of a in both sides of this equality here, right? So that means that x1 plus x2 plus m over 3 is equal to x, which means that 3x is equal to x1 plus x2 plus m. So call this equation 1, right? And then from the exponent of y, we have that y1 plus y2 plus n over 3 is equal to y, which implies that 3y is equal to y1 plus y2 plus n. And we'll call this equation 2 now. Good. And then since this is the GM, right, we know that m is a natural number since that's part of what we're given in the question. So from 1, we have that 3x is equal to x1 plus x2 plus m. And since m is a natural number, it means that m is greater than or equal to 1. So this is greater than or equal to x1 plus x2 plus 1, which implies that 3x is greater than or equal to x1 plus x2 plus 1. Good. And from 2, we have something similar too. We end up having that 3y is y1 plus y2 plus n. And since n is a natural number, n is greater than or equal to 1. So this is greater than or equal to y1 plus y2 plus 1, which implies that 3y is greater than or equal to y1 plus y2 plus 1, right? And so we'll go back here now. We'll look at this. We'll see that the three numbers we have are a b raised power 4, a cubed b squared, and a raised power 6b, right? And then what will come here? So let's assume that ab raised power 4 is the GM. So if ab raised power 4 is the GM now, it implies based on 1, right, that 3 times 1, since x is the exponent of the GM and x1 and x2 are the exponents of the other two numbers, it means that this 3 times 1 now has to be greater than or equal to the exponents of x of the other two numbers, 3 and 6, right? So it means that 3 plus 1 has to be greater than or equal to 3 plus 6 plus 1, which implies that 3 has to be greater than or equal to 10, which is a contradiction. So, like, just to explain what happened here, because it may be a bit confusing at first. Don't forget that here, right, we assume that a raised power x, b raised power y is the GM. And then we now made a raised power x1, b raised power y1, and a raised power x2, b raised power y2 to be the other two numbers, right? And a raised power m, b raised power n is that last one that we got is not the GM. So assuming that a b raised power 4 is the GM, the other two numbers here now will be there will be a cubed b squared, right? A cubed b squared and a raised power 6b. So the value of x1 will be 3, and the value of and value of x2 will be 6. And since we have that 3x from here is greater than or equal to x1 plus x2 plus 1, it means that 3 times 1 has to be greater than or equal to 3, which is x1, plus 6, which is x2 plus 1. And then we'll end up having that 3 is greater than or equal to 10, but that's not possible. So that's where we get that contradiction from. And then assuming that a raised power 6b is the GM now, a raised power 6b. So if a raised power 6b is the GM, this implies also that 6 times 1 has to be greater than or equal to So in this second part now, we're going to make use of the inequality we have in equation 2, right? So in equation 2, we have that 3y is greater than or equal to y1 plus y2 plus 1. And here y1 is going to be 1, which is the exponent of b. So we have that 3 times 1 here has to be greater than or equal to the powers of b of the other two numbers are 2 and 4, right? So that means that this has to be greater than or equal to 2 plus 4 plus 1, which implies that 3 has to be greater than or equal to 7. But this is a contradiction. So I'll just explain what I explained for the other one. So in this case now, if a raised to power 6b is the GM, we know the other two numbers now are going to be ab raised to power 4 and a cubed b squared. So this is going to be y1 and this is going to be y2. And then in a raised to power 6b, 1 is going to be y. And then from equation 2, we have this inequality. Sorry, not here. From here, we have this inequality that 3y is greater than or equal to y1 plus y2 plus 1. So it means that, make use of that. It means that 3 has to be greater than or equal to 7. But that's not possible. And so that gives us the contradiction here. And then what we have done is that we have shown that this number here, we showed that a b raised to power 4 can't be the GM. We also showed that a raised to power 6b can't be the GM. And this one too can't be the GM. And since one of them has to be the GM, it has to be a raised to power 3, b raised to power 2. So this means now that a raised to power 3, b raised to power 2 is the GM. And then we're going to calculate the GM of, so the other two means that a raised to power 3, b raised to power 2 is the GM of a b raised to power 4, a raised to power 6b, and a raised to power n, b raised to power n. So the GM, so this means that the GM of AB raised to power 4, a raised to power 6b, and a raised to power m, b raised to power n is a cubed b squared. And when we calculate the GM of these three numbers here, it's going to be equal to the third root, since there are three numbers, of ab raised to power 4 times a raised to power 6b times a raised to power m, b raised to power n. And that's going to be the third root of a raised to power 7 plus m, b raised to power 5 plus n, right? And this is going to be a raised to power 7 plus m over 3b raised to power 5 plus n over 3. And we know that the GM of these numbers is a raised to power 3 b squared. This implies that the exponents of the exponents of a on both sides have to be equal. So 7 plus m over 3 has to be equal to 3, which implies that 7 plus m is 9 and m is 2. And for b, we have that 5 plus n over 3 has to be equal to 2, which implies that 5 plus n is equal to 6 and n is equal to 1, right? And since the question tells us to find what m plus n is, it means that m plus n has to be equal to 3. And that's how we solve the question.